Good morning, everyone. Okay. Good morning, everybody. You are all welcome to this morning class. We're doing revision on Trig and Analytical geometry. It's a revision week, and we are going to solve a lot of examples. Is that clear? That will help you. Okay. We have here example. If cos theta equals to 12 over 7, sorry, 3 all over 7, excuse me, 3 all over 7, where theta is an acute angle. Evaluate cos 2 theta, amen? So it is simple as ABC. Yeah. So what we need to do, let us write solution. Please, I want you to like, comment, and make sure the attendance, the normal way we take our attendance, and share. Is that clear? So let's write solution. Amen. I hope you are seeing the board clearly. Invite others. Let's write solution. Okay. So we have been given cos theta. So is it bad for us to draw our right angle triangle? Let us say using Sukatua. Let us have a right angle triangle. Amen. Okay. The right angle triangle, which is angle theta. Here is opposite hypotenuse, right? Adjacent. Okay. So we name here y, r, and x. True or false? It's true, right? Okay. So if you can see what I am saying, it's not difficult. Let's define car. Car. It means car. Car means what? Adjacent over hypotenuse. Over hypotenuse. It means this is cos theta. Adjacent is x all over what? R. So it means since cos theta has been given as cos theta is equals to 3 all over 7, right? Okay, so our x is 3, then r is what? 7. Yeah, it means we need to find, they said we should use this one to evaluate cos 2 theta and sin theta plus cos theta. Amen. So what we need to do, we have to find the value of what? Sin theta. So if we are to consider sin theta, it means here. So let's define so. So is equals to opposite all over hypotenuse. It means so is sin theta, right? So is sin theta. Amen. Are you following? Okay. Yeah. Okay. So if you can see what I am saying here, it means it means opposite of hypotenuse. This is y all over what? R, right? Okay. But arrow has been given, true or false? True or false? And here has not been given. So it means we can use Pythagoras theorem to obtain y, true or false, by applying Pythagoras theorem so that we can obtain our sine theta. So by Pythagoras theorem, it means our r squared is equals to x squared plus y squared, true or false? Then our arrow is what? Arrow has been given as what? 7. 7 squared equals to x is 3 squared, but y is unknown, true or false? Do you agree with me? So if really you agree with me, it means 7 squared is the same thing as 7 times 7, which is what? 49. Am I right? Okay, so here will be 49 minus 3 squared. 3 squared is 3 times 3, which is equals to 9. True or false? So here is 9 plus y squared. Then this is this implies that y squared is equals to 9 crosses the sign of equality becomes minus 49 minus 9. So it means our y is going to be 49 minus 9, y squared, sorry, is equals to 40. Is equals to 40. True or false? Look at the board very well. True or false? Many are still sleeping. The lazy ones are still sleeping. True or false? That is true, right? That is true. Okay. So far, so good. So what we need to do here is, we take the square roots. When we take the square root, y will be equals to square root of 40. Yeah. So, what is the square root of 40? Let us try it this way. Okay, 2, 22, 10, right? 2, 5, 5, 1. Am I right? So it means 2 times 2, 4, 8. True or false? So square root of 8 times 5, this is the same thing as square root of 8 times square root of 5. So this is going to give us square root of 8 times 5, which is the same thing as what? Square root of 8 times square root of 5. Then this will give us a y will now be equals to 2 root what? 2 root 2, right? Times root 5, which is the same thing as 2 root 10. True or false? True or false? Look at the board, everybody, and tell me whether I'm right or wrong. True or false? Look at the boards. True or false? It's true, right? Okay. Bello Musa. Okay. Bello Musa. So this implies that our sine theta is equals to what? Y is 2 root 10. R is what? 7. Right? Okay. So now let us evaluate this. We are asked to evaluate cos 2 theta all over. So let's do it together. Amen. Okay. Okay, so if you agree with me, it means sine theta is equals to 2 root 10 all over 7. Then y is equals to 2 root 10, right? And they said we should evaluate this as simple as ABC. So let us evaluate this. It means cos 2 theta all over what? Sine theta plus cos theta. But let us note that our cos 2 theta is equals to cos square theta minus sine square theta. Amen? Amen? Do you agree with me? Okay. So if you agree with me, it means we are going to write, instead of this is cos square theta minus sine square theta all over sine theta plus cos theta. So what is our cos theta? Cos theta is 3 all over 7. So instead of cos square theta, we write this is equals to 3 all over 7 all in square minus what is sine theta? Sine theta is 2 root 10 all is, okay, sorry, let's do it this way, all over 7 all in square, then all over sine theta 2 root 10 in plus 7. Am I in order? Am I right? True or false? Okay. So if you agree with me, here we are going to have 9 all over 49, then minus here 4 open bracket 10 all over 49. I know some of you will ask how do we have the 10. Then here we take the LCM, true or false? LCM is have 2 root 10 plus 3 all over what? 7. True or false? Then the LCM here will now be 49. So here we are going to have 9 minus 4 times 10, 40 all over 49. Then all over 2 root 10 plus 3 all over 7. No, we cannot have this, but we can subtract this to give us, this is equals to, it's going to give us minus 31 all over 49 all over 20 root 10 plus 3 all over what? 7. Do you agree with me up to this point? True or false? It's true, right? So what we need to do it there, what we are going to do something there. Look at it here. This is just the same thing as A all over B divides C all over D. Then A all over B times D all over C. You agree with me? So if you can see what I am saying here, so here will now be equals to minus 31 all over 49 divides 2 root 10 plus 3 all over what? 7. So this 7 will come up minus 31 times 7 all over 49 open bracket 2 roots 10 plus 3. Yeah. You can stop here, no problem. So this is where we are going to stop. Because they said evaluate this. So we're able to evaluate it at this point. Any question, please ask so that we can move to the other questions. Do you have any question? Drop it in the comment section. Any question, yes or no? Any question? No question. So it means we can proceed, right? Okay, let's proceed. Let us proceed further. Let's proceed. Okay. Yeah, another one is show that or proof. Another example. Prove that 1 plus sine theta 1 plus sine theta all over cos theta plus cos theta all over 1 plus sine theta equals to 2 all over cos theta. Amen. We are going to look at this idiot this morning. Amen. Okay. So let's proceed. So what we need to do here is we don't need a prophet to tell you. You don't need a prophet to tell you when you come across equations of this form, although they are trigonometrical equations. What you need to do is first consider the LCM. The LCM of this and this will be what? The product of these two of us. So let's consider the LCM. Let's have it in this form. Okay. Cos theta, open bracket 1 plus sine theta. Amen. So this is how you are going to consider the LCM. So this coming to divide this and this will cancel. Remember this, two of us. So this implies that you use this to multiply. It means we are going to have 1 plus sine theta all in brackets times 1 plus sine theta close bracket. What do we have here? Plus, right? Plus this to divide this and this will cancel. We are going to have cos theta times cos theta. So cos theta times cos theta. Amen. Then this will be equals to 2 all over cos theta. Do you agree with me? Amen. Do you agree with me? Any question? If you have any question, please drop it in the comment section so that we look at it and we proceed. Any question? No question? Okay. There is no question. We can proceed, right? Let's proceed if there is no question. So as you can see, what we need to do, use this to multiply this. So 1 times 1 is 1. 1 times sine theta, going to give us sine theta plus sine theta times 1 plus sine theta, amen. Then plus sine theta times plus sine theta plus sine square theta. Yeah. Then here, cos theta times cos theta will give you what? Plus cos square theta and all over, amen, all over cos theta, open bracket 1 plus sine theta equals to 2 all over cos theta. Amen? Yeah. That's right. Okay. So if you can see what I am saying, it implies that okay. It implies that yeah. I hope I'm right. Coming, but something is missing. This one times this one times this. This one times this, this, and this one times this, this. Okay? Are we sure that we are in order? Let's look at it again and again. Excuse me. 1 plus theta over cos theta 1 plus yeah. Okay, yeah, we are in order. Look at it here. Here, let's go back to our Trig. Look at note that sin squared theta plus cos squared theta is equal to 1. So it means here, this and this is 1, whole of this. Give us 1. True or false? Go back to your identity. Trig identity. Go back to your trig identity. So if you agree with me, if you can see what I have seen on the board, you don't need a prophet to tell you. Plus this, there will be 1 plus sin theta plus sin theta, 2 sin theta. Here is what? Plus 1, because this and this will give us 1. Then all over cos theta, open bracket, 1 plus sin theta, amen, equals to 2 all over cos theta. Can you see the way I'm breaking it down? So you don't need a prophet to tell you. Here will now be this plus this, going to give us 2 plus 2 sin theta all over cos theta, open bracket, 1 plus sin theta, then equals to 2 all over cos theta. Okay? Yeah. So, look here, look up, look at the numerator. Please, everybody, look at the board very well. Look at the board. Okay, look at the board very well. At this point, look at the numerator. If you can see what I am saying, we've gotten the right answer, true or false. Why? Because here 2 is common, so we can factor 2 out to give us 2 open bracket 1 plus sin theta close bracket all over. Okay, let me just do it down here. 2 open bracket 1 plus sin theta, amen, all over cos theta, open bracket 1 plus sin theta, then equals to 2 all over cos theta. Can you see now? So it means this and this will go. Is equals to 2 all over cos theta. And this satisfies the proof. Yeah. So any question, please. Look at the board and ask your question. Ask your question. Oh, John Kingsley. 1 plus sine. Oh, you don't understand? Look at it here now. If we have 2 plus 2 sine theta, John, Kingsley, listen. What is common here? 2. We factor out 2. 1 plus sine theta. John, listen. No. By the time you use this one to multiply this, you get back 2. Use this to multiply this, you get back 2 sine theta. It's the same thing now. Is that clear? I'm just trying to play around so that at the end of the day, we are going to have the right hand side. What they want you to show is make sure at the end of the day, both the left hand side and the right hand side are equal. That is what we are trying to do. Amen? Okay. Yeah. John, are you satisfied? You are satisfied, right? Yeah. Shaibu. We can proceed now, right? Okay, let's proceed to consider my examples. Okay. Now the question says, find the equation of the cycle of the triangle. Find the equation of the cycle, the triangle whose vertices are P1 1, 0, P2 minus 1, 2, and P3 3, 7. Okay, look at this question. We want to consider this question. It's simple as ABC. Okay, so let's proceed. Let's proceed. Looking at this question, It seems you are kind of confused, but I will advise you not to be confused because they added something here. The triangle whose vertices are this, this, and this. But I want to tell you that the question says find the equation of the cycle. So what will first come into your mind is if you go back to the general equation of the cycle. So we now see, let's the equation of the cycle B, our general equation of the cycle is of this form, is x squared plus y squared plus 2gx plus 2fy plus c equals to 0. True or false? Look at the board. True or false? It is true, right? Okay. So if you believe that it is true, say the vertices of the triangle, we have 0.1, 0.2, 0.3. So we now write at point P1, 1, 0. It means your x is this, y is this. True or false? So here will be 1 raised to the power 2 plus 0 squared plus 2g of 1 plus 2f of 0, y is 0, right? Plus c equals to 0. So we can make this equation 1. So as you can see, this will give us 1 plus 2g, because 2g times 1. This is 0 plus c equals to 0. This is equation 2. True or false? And by the time we bring 1 to this side, our 2g plus c is equals to minus 1. So this is equation 3. Do you agree with me up to this point? Then at point P2, the same thing applicable. Is that clear? Till we get to point P3. Do you agree with me? Any question, please? Any question? No question. Okay. Yeah, if there is no question, it means we can proceed. Civil engineering student, if there is no question, we can proceed, right? Okay, so at point minus 1, 2, right? So let's look at it together. These are x, these are y. So here will be minus 1 all in square plus y, this is 2 all in square plus 2g minus 1, amen, plus 2f of 2 plus c equals to 0. This is equation 4. Then here is plus 1. Here is plus 4 minus 2g plus 4f, then plus c equals to 0. This is equation 5. True or false? True or false? So we can have this to give us 5 minus 2g plus 4f plus c equals to 0. So by the time this 5 crosses the sign of quality, this is equation 6. We are going to have 2g plus 4f plus c equals to minus 5. This is equation 7. Do you agree with me? Any question, please ask. Do you have any question? No question. Okay? It means we can proceed, right? Okay, let's proceed. Let us proceed. Let's proceed. So it means at point 3, 3,7. Here is 3 square plus 7 square, right? Then plus 2g of 3 plus 2f of 7 plus c equals to 0. Amen. This is equation 8, right? Then 9, 49 plus 2g times 3, 6g, 2f times 7, 14f plus c equals to 0. This is equation 9. So by the time we add this, we are going to have 58 plus 6g plus 14f plus c equals to 0. This is equation 10. Do you agree with me? Amen? Okay, so by the time this one crosses the sign of equality, I'm going to have 6g plus 14f plus c equals to minus 58. This is equation 11. So now we want to find the equation for us to obtain the center of this very equation. So if you can see what I am saying, look at equation 3, 7 and 3 and 7. We can eliminate C and F? Okay, let's try it. Let us add in equation 3 and 5. We are going to have, if we add them, this and this will cancel. Then we are going to have 4f plus 2c, which is equals to, by the time we add this and this, we are going to have minus 6. This is equation 12. Right? This is equation 12. Are you following? Okay, this is equation 12. So, you know that we can eliminate okay, that be possible. Okay, let's look at it. Look at it together. Look at it together. Are we sure that we can excuse me? Okay? When we divide 2 by 2, equation 12, we are going to have 2f plus c equals to minus 3. This is equation 13, right? So what do we do? What do we do? If we substitute in we make c equals to minus 3 minus 2f, we assume this one to be 14, right? Then if we substitute in this here, what do you think will happen? When we substitute this, here, okay, as it is, we can just assume f to be equals to 1. Otherwise, we won't be able to solve this problem. Or c as constant, if we setting c equals to plus 1, from here, it means we are going to have 2f equals to minus 3, 2f plus 1 equals to minus 3, then 2f is equals to minus 3, this crosses the sign of equality minus 1. So as you can see, our f will now be equals to 2f, now be equals to minus 4, then f now be equals to minus 4 over 2, which is f is equals to minus 2, right? You agree with me? Any question? We have to set c equals to 1, otherwise we won't arrive at the answer. Okay, so let's proceed further to consider. We've gotten our c as 1, then f as minus 2. So let's find our g. At least from here, from equation 1, we can obtain our g, two of us, without stressing yourself. So from equation 3, to obtain g, here, anywhere you see c, you put 1. So our 2g plus 1 from equation 3, we have that c is 1 equals to minus 1. This crosses the sign of equality becomes minus. So 2g equals to minus 1 minus 1. So this implies that our 2g is equals to minus 2. Then this means that our g is equals to minus 2 all over 2. Then g is equals to what? Minus 1. So it means therefore, excuse me, g equals to minus 1, f equals to minus 2, and c equals to 1. Okay? And c equals to 1. So let's check whether we are right or wrong. As you can see now, you don't need a perfect one. So this is how you are going to solve this problem. Let's check whether we are right or wrong. Look here. let us use equation 3 to check 2g plus c equals to minus 1. Whether at the end of the day we will get the right answer. So since our c is what? 1, our g here is minus 1. So 2 open bracket minus 1 plus 1 equals to minus 1. This times this, minus 2 plus 1 equals to minus 1. You can now see that minus 2 plus 1 is minus 1 equals to minus 1. So it means our answer, the answers are what? Are right. Likewise, you can check with this. Check with equation 7. Equation 7. Whether at the end of the day you still arrive at minus 5 is possible. This is plus 2. This is minus 8 plus 1. So plus 2 minus 8 plus 1. It means you can now see that minus 8 plus 3 is minus 5 equals to what? Minus 5. We are right. So this is how you are going to approach it. Any question, please? Do you have any question? No question? No question. Okay. We are moving. There's no question. I want to clean everything. Can go ahead and clean, right? Okay. Express the following radian to degree of 1.4 radian, I 1.4 radian, I pi all over 3 radian, I 4.6 4.6 radian. I think we'll be needing your calculator. So we are going to instead convert these radians because they are in radians to degree. So what are we going to do? Somebody should tell us. Somebody should tell us. Okay. So solution I 1.4 radian will be equals to what? 180 degree all over pi times 1.4. Because we want to convert it to what? Degree. So what is the answer? Pi is 22 all over 7. Somebody should tell us the answer. I think you are supposed to have 80 point 20 degree. Then II pi all over 3 equals to 180 all over pi times pi all over 3. This and this will cancel. Then 18 divided 3 is 6, right? 1. So here will be 60 degree. Then you finish III 4.6 radian. Now be equals to 180 all over pi times 4.6. Yeah, what is the answer? Write the answer. The II. I need the answer. Use your calculator, please. Yes, I'm waiting. Use your calculator. Okay. Jimo Abdulatif, thank you very much. 263.56. 263.56 degree. Is all right. Okay. Gentlemen and ladies, thank you for your time. Your time has been exhausted. So let us welcome calculus students from chemical, agric, and electrical. You are all welcome to calculus class this morning. How was your night? Thank you. You are welcome. Okay, that is that. So till next week, the same time, the same venue. I wish you all the best. Okay, calculus students, you are all welcome. Yeah, let's go ahead and solve some problems. Okay. Let's go ahead and begin to solve some problem. One of the problem says if y equals to tan theta, find the y all over the theta by the method of quotient rule. Okay. Amen. Calculus student. I'm not saying electrical, agric, chemical. You are not ready, I'm going to quit. As simple as ABC. It's okay. Let's look at this question. It's a very beautiful question. And it's very simple. Amen. Let's write solution. Our y, the function was given as tan theta. Yeah. The same we should use by the method of quotient rule. So it means quotient rule, the formula is our dy all over dx is equals to either u dv all over dx minus v du all over dx all over v square, or your dy all over dx is v du all over, since we are talking about theta, so here we are not going to include x, but theta. Is that clear? Take note, it's very important. Minus u dv all over the theta all over what? V square. Okay, so how are you going to use quotient rule to solve this? It's simple as ABC. Go back to Trig. Note that sin theta is also the same thing as what? Sorry? Tan theta is also the same thing as sin theta all over what? Cos theta. So can you see your quotient rule now? So here now be, instead of y equals to tan theta, this implies that this is sin theta all over cos theta. It means y is equals to sin theta all over what? Cos theta. Are you following? Do you agree with me? Do you agree with me? Okay. So if you agree with me, look at it here. So, this is always in the form u all over v. Is this formula we use, or you can use this one, no problem. So you don't need the prophet to tell you your u is sin theta, v is cos theta. So we now write, let u be equals to sin theta and v be equals to what? Cos theta. True of us. So what we need to do here is, we look at the formula. We have ordinary v, we have d all over the theta, and we have ordinary u, we have the v all over the theta all over v squared. We've gotten our ordinary u and v. What next is for us to differentiate to obtain our du all over the theta. So we'll differentiate this function with respect to what? Theta. So our d all over the theta now be equals to cos theta if you differentiate sin theta, and the v all over the theta is equals to minus sin theta. Amen? Okay? Do you agree with me? So we have to go by this formula. It means our dy all over the theta is equals to, what is our ordinary v? Our ordinary v is this. So cos theta times what is our du all over the theta is cos theta. Amen? Then what we have here minus. Then what is our u? Ordinary u. Ordinary u is sin theta. Is sin theta. Then what is our div all over the theta is this minus sin theta. Amen? And all over v squared. So what is our ordinary v? Is cos theta all in what? Square. Amen? Do you agree with me? Any question? Do you have any question? Not seeing electrical student, there's only one student I'm seeing, Amayo from electrical, and who is chemical and agric. I'm not seeing them. It's okay. So, as you can see now, you don't need a prophet to tell you. It means we are going to use this to multiply this, and this to multiply this. I will take it step by step. Excuse me, so that you understand it better. Amen? Okay? So here will now be dy all over the theta is equals to cos theta times cos theta. I'm going to have cos squared theta. So let's use this minus to multiply this minus. Here will be plus. Then sin theta times sin theta. I'm going to have sin squared theta. All over. This is the same thing as cos squared theta. Do you agree with me? Amen? So now let's go back to our trig identities. We were taught trig. So it means note that cos squared theta plus sin squared theta is equals to 1. So it means this is 1. So instead of this, we are going to write our dy all over the theta is equals to 1 all over cos squared theta. Either you leave it like this, or this is the same thing as, or you know that sec theta is equals to 1 all over cos theta. Two of us. So if we now have 1 all over cos squared theta, this means that this is the same thing as sec squared theta. Take note. So this is the same thing as our dy all over the theta will now be equals to sec squared theta. So in other words, if you differentiate tan theta, you are supposed to have either 1 all over cos squared theta or sec squared theta. Any question before we proceed further? Drop it in the comment section. Do you have any question? Do you have any question? So we can proceed, right? We can proceed, right? Okay. Let's proceed if there's no question. There is no question, let us proceed. I want to clean this. There is no question. Let's proceed. Let's proceed. Let us proceed. Amen. Solve the differential equation. Solve the differential equation. That is d square y all over the x square minus 4 dy all over the x, then plus 4y equals to 0. Amen. Okay. Before I go ahead to solve this differential equation, I'm going to explain the differential equation, what differential equation is all about. Differential equation constitutes degree, type, and order. Is that clear? So, assuming if we have a dy all over the x plus by equals to 0. Now, somebody asks you, what is the name of this differential equation? The name of this differential equation is first order DE. Why? Because the order here is just one, true or false. So this is first order differential equation. Now, assuming you are asked, what is the type of this differential equation? The type of this differential equation is homogeneous differential equation. Why is it called, what makes it an homogeneous differential equation is that the right hand side is 0. Is that clear? So if you see a differential equation of this form equals to 0, know that this is an homogeneous differential equation. That is the type of the differential equation. But assuming the right hand side is equals to exponential x, it can never be homogeneous. This will now be non-homogeneous non-homogeneous DE, differential equation. You can now see that the differential equation is not equals to 0, true or false. So take note. So can you see the difference between homogeneous and non-homogeneous differential equation? So whenever you are asked to, sometimes they may ask, classify the following DE, differential equation, into order and degree. Is that clear? It will do you good. It will do you good as long as advanced calculus, it will do you good. So as I was saying, so it means you can identify this. We are talking about this 0, but if it is in this form, dy all over dx plus by equals to exponential this. This is a non-homogeneous differential equation, while this one is homogeneous. Dy all over dx plus by equals to 0. This is an homogeneous differential equation because of equals to 0. So now, assuming you are classify the following D into type, order, and degree. Yeah, when we say degree, the degree of a differential equation is, as you can, if you cycle this, you can now see that it is raised to power what? 1. True or false? So the degree of this differential equation is degree what? 1. Take note. So let's fix example with this. Maybe we have this d cube dy all over the x cube plus 4d square y all over the x square plus 3 dy all over the x plus 4y equals to 0. Then 2 d square y all over the x square minus 4 dy all over the x square dx, sorry, plus 4y equals to 0. Then 3. Let's have okay, here let us have raised to power 10. Here is raised to power 6. Then here is raised to power 2. Here is raised to power 3. Here is raised to power 7. Then we have d square y all over the x square, all in square bracket raised to power 2 minus 4 dy all over the x raised to power 6 plus 4y equals to exponential x. Okay. Yeah. We learn exactly. So now, here is the question. True or false? They said classify the following differential equation into type, order, and degree. So now, 1, we have d cube y all over the x cube all in bracket square plus 4 d square y all over the x all in bracket raised to power 10 plus 3 dy all over dx all over raised to power 6 plus 4y equals to 0. So if they are talking about the type of this first one, the differential equation, the type of this differential equation is, since it is equals to what? 0. So it means the type will now be what? Homogeneous, true or false? Homogeneous differential equation. Homogeneous DE. Then they said order. The order of this differential equation. Look at what is inside the bracket. Ask yourself, which one is the highest? We have d squared. We have d raised to power 3. dy over dx. So inside this bracket, look at it. Which one has the highest power? The highest order, sorry. Is this first one true or false? Is this first one true or false? It's true. Do you agree with me? Yeah. It is true. This first one. So the order of this differential equation is order 3. Order 3. This first one. Then the degree. The first one, the degree of, look at the first differential equation. If you want to consider the degree, it is not difficult. The degree of this differential equation is, what is the highest order in this differential equation? Is this true or false? We know that we have all in bracket raised to power 2, all in bracket raised to power 10, all in bracket raised to power what? 6. I know some of you want to come and write that the degree of this differential equation is 10. It is lie. You are not correct. It is not true. Why? Because we pick the degree according to the highest order. So the highest order, what is the highest order? The power of the highest order here is raised to power 2, true or false? So the degree of this differential equation is 2. Then let's come to this one. With what we have done so far, you don't need a prophet to tell you. So what is the type of this differential equation? Since it is equals to 0, so the type is what? Is going to be what? Homogeneous. True or false? Homogeneous DE. Differential equation. Then the order, you don't need a prophet to tell you. This one is in first order, this one second order. So it means this second order supersedes everything here. So it means the order of this differential equation is second order. Order 2 or second order. Then let's consider the degree. Let's consider the degree. Now the degree of this differential equation, you don't need a prophet to tell you. It's not 7, but what? It's 3. Then here is the type of this differential equation is going to be what? Non-homogeneous, because it is equal to exponential x, true or false? So here is non-homogeneous DE. Is that clear? Non-homogeneous DE. Hope you are following. Are you following? Non-homogeneous DE. Okay. So then the order of this differential equation is second order. Order 2 or second order. Then the degree of this differential equation is 2. The degree is 2. So this is how to classify a differential equation. Is that clear? So please take note, it's very important. Are you following? Most especially when you get to HND. Yeah. So Now, so now let's consider what is it called? The nature of the root. Because at the end of the day, we are going to solve to obtain, or reduce this to what is called auxiliary equation. Auxiliary equation. Auxiliary equation. We are going to reduce this second order differential equation to auxiliary equation. That is, it is in form of a quadratic equation. Just like this. Ax squared plus bx plus c equals to 0. Yeah, it is no more called a quadratic equation, but it is called what? An auxiliary equation. Why? Because we are able to what? Extract it from what? A differential equation. Is that clear? So that is why it is called an auxiliary equation. So you cannot call it what? A quadratic equation. Take note. Okay. So now, as long as differential equation is concerned, second order differential equation is concerned, you must reduce it to what? An auxiliary equation. Then it means that will lead us to obtain our what? X1 and X2. But here we are going to use, instead of X1, M1 and M2. So take note. And M2. So the roots, if the roots are distinct real roots, are distinct, that is M1, let me say, equals to 1 and M2 equals to 2. It means the general solution of this differential equation, the general solution of this differential equation will be written in this form. Y equals to A exponential mx1 plus B exponential mx, that is, sorry, m1 and m2x. But in some textbooks, they make use of y equals to c1 exponential m1x plus c2 exponential m2x. Take note. It's the same thing. Either I use A and B because here A, here is B. But if you are using the same thing, it means one can still use A1, A2. Take note. Is that clear? Do you agree with me? Are you following? Okay. So if you agree with me, it means at the end of the day, after solving, you have m1 equals to 1 and m2 equals to, let me say, minus 2. It means you just substitute in. It means our general solution, this G means general solution. C1 exponential m1 is what? 1. So 1 times x is x plus C2 exponential m2 is minus 2. Minus 2 times x minus 2x. This is how the general solution will look like. Take note. But if they have the same roots, that is, at the end of the day, after solving, you can now see that m1 is equals to 1 and m2 equals to 1. It means m1 equals to m2, which is equals to 1. You can now see that they are the same. The roots are the same. It means this is what you are going to use. It means y is equals to a exponential m1x plus bx exponential m2x. Can you see now? Or put or here, or y is equals to c1 exponential m1x plus c2 x exponential m2x. Can you see the difference, right? You see the difference between this and this. There is x attached to this at the end of this thing. Implies that this is what I have seen. This is the same thing as something is common. Exponential x is common. We can factor it out. C1 plus C2x, sorry. Yeah. So this and this, they are all the same thing. The reason why I'm doing all these things will soon be here anytime soon. That is why I want you to take notes so that when I'm substituting or writing anything, you won't be confused. Is that clear? Any question? So that we proceed further to solve the differential equation. Is that clear? Please, I want you to share. Okay, this differential equation. Let's go ahead. Okay, so how can we solve this second order differential homogeneous differential equation? Is we have to look for a solution. Is that clear? So what we do is we write solution. It means sometimes, don't be surprised, sometimes this differential equation that you are seeing, d squared y all over the x squared minus 4 dy all over the x plus 4y equals to 0. We can present it in this form: y prime prime minus 4y prime plus 4y equals to 0. It means this and this, they are the same thing. The difference is the notation. The notation here is prime prime. True or false? Then we can use y dot dot minus 4y dot plus 4y equals to 0. So don't get confused. Is that clear? Don't be confused. Any one of these you see is the same approach you are going to use. Is that clear? So it means when you are differentiating, you are just going to change the notations. Is that clear? Take note. Okay. So if you agree with me, so now let's look at it together. Let us consider this. This second order differential equation is this. We now write since the dependent variable is y, right? So let y be equals to a exponential what? mx. Since the independent variable is x, we use mx. But supposing here is t, you make use of t here. Take note. It means assuming here will now be dy all over d square y all over dt minus 4 dy all over dt plus 4y equals to 0. That is what I mean. You can now see that the independent variable here is t. So the solution to this differential equation will now be y equals to a exponential mt. Take note. If it is theta, it's the same thing. Is that clear? Take note. It will do you good. Okay. So if you agree with me, if you can see what I am saying, we now say let y equals to this. It means this is a function, true or false. And let's look at this. This is a differential equation. So it means we have to differentiate this. How many times? Twice. And substitute it into this second order differential equation. So let us differentiate this. Depends on the notation. Here they use the y over the x. So let us use the y over the x. So if we use the y over the x, it means our dy all over the x is equals to what? If you differentiate this a is constant, differentiate exponential mx, you are going to have exponential mx. Then note that this is the same thing as y prime, true or false. Then we have to differentiate this so that we'll be able to substitute it into this differential equation. It means it's going to be d squared y all over the x squared equals to differentiate this whole ma constant. You are going to have m squared a exponential mx. This is the same thing as what? Y prime prime. True or false? So what you need to do here is for you to substitute it, or this is the same thing as y dot, and this is also the same thing as y dot dot. So any one of the notations you want to use, you can just apply it. Is that clear? So it means this, we are going to substitute in this or here. Since dy over d square y over dx is equal to m square a exponential what? So instead of this, we write m square a exponential mx. What is here? Minus 4 times dy over dx is this m a exponential ma exponential mx. Then what do we have here? Plus 4. What is your y? Your y is a, amen, a exponential what? Mx, which is equals to 0. Amen. True or false? Okay. So it means this is the solution differential equation. So now look at this equation now. Tell me what you are saying. Except you are blind mathematically. Tell me what you are saying. Okay. So if you can see what I am saying here, look at the left hand side. What are you seeing? Look at it very well. Look at the board very well. Amen. Amen. Okay. What are you saying? What is common in the left hand side? This left hand side, what is common? If you can see what I am saying. A exponential mx is common. True or false? You factor it out. You factor it out. A exponential mx is common. Open bracket. It means here will be m squared minus here will be what? 4m. Then here will be plus what? 4. Which is equals to what? 0. So if a exponential mx does not equal to 0, it means our m squared minus 4m plus 4 equals to 0. Then this is what we call the auxiliary equation. This is the auxiliary equation. Are you seeing now? Are you seeing now? Can you see what I was telling you in the beginning? You can now see that it is in form of what? A quadratic equation. but it is no more quadratic. We are advanced equation. Are you following? Do you understand? So it means we are going to solve it the way we solve a quadratic equation. Do you agree with me? The way we solve a quadratic equation. Is that clear? Is that clear? So it means here you know how to solve a quadratic equation. The factors are what? M equals to 2, M equals to 2. M squared minus 2M minus 2M plus 4 equals to 0. True or false? This is the same thing as this auxiliary equation. So you bracket it M squared minus 2M all in brackets minus 2M plus 4 equals to 0. What is common here? M. Factor it out. M minus 2. Then what is common here? Minus 2. Factor it out. Minus 2. Can you see now? So you can now see that the brackets are the same. So M minus 2 is equal to 0. Or M minus 2 is equal to 0. You can now see that our M1 is equal to 2 or M2 is equal to 2. So you can now see that M1, they are all the same. M1 is equal to. So the general equation will now be, since they are the same, will now be, this is what we are going to use. Y, note that this G means the general equation. Y equals to C1 exponential M1x plus C2x exponential M2x. Because the roots are equal, they are the same. That is why we are adding this x. Is that clear? So it implies that our general solution now be C1 exponential M1 is the same as 2. So 2 times x, 2x plus C2x exponential 2x. Yeah, this is how you are going to solve this differential equation. So, assuming you are asked, what is the solution to this second order differential? The solution of this second order differential equation is this: y equals to a exponential what? Mx. Yeah, that gives us this solution. Do you have any question? Please ask. Any question? Yes or no? No question? Okay, if there is no question, let's proceed. Let's proceed further. If you don't have questions. No question? So you mean we can proceed, right? Okay. So I can clean all of this. Okay. Let's proceed further to consider more examples. One of the examples says, show that the limit x tends to 0, x minus 2 absolute value of x, then all over absolute value of x exists. Amen? Yeah, we want to look at it together. Okay. So how can we show that this limit exists? It's simple as ABC. We can easily show for a limit to exist, it means the left hand side and the right hand side must what? Be equal. You must take note of that. That thing must be the first thing you should consider. For a limit to exist, the left hand side and the right hand side must be equal to what? They are all equal. Is that clear? Both the left hand side, just like your right hand side and your left hand side, they are equal. So it means the limit exists. So let's proceed further to show whether this limit exists or not. Okay, so the right solution, since we are talking about left and the right hand side, in the number line, we assume here to be what? 0, right? So it means this is our x. Our x here is positive. Then our x here is negative, true or false. So this is the right hand, this is the what? The left hand. So for us to show that the limit exists, we have to test both the right and the left hand side. So here we now write limit x tends to, this plus means right hand side. Is that clear? X minus 2 absolute value all over, if you see this, this is known as either absolute value or magnitude, or what again? Or modulus. Take note. Is that clear? So whenever you see something of this form, in mathematics, it can be called absolute value or magnitude or modulus. Take note. Is that clear? Very important. Take note. Take note. Okay. So now we want to consider the right hand side limit. So we now assume that if, since here is on the right hand side, so if the absolute value, if the modulus is equals to plus x, since we are talking about what? The right hand side. So it's going to be what? The modulus or the absolute value is going to be what? Plus. So it means the limit x tends to 0 plus x minus, it means instead of absolute value or modulus x, we are going to write what? X. So minus 2 open bracket x all over x. Then this is the same thing as limit x tends to 0 plus x minus 2 times x is minus 2x all over what? X. Do you agree with me? So this implies that if you can see what I am saying, look at it. When we have x minus 2x, we can still rewrite this idiot in this form. X is common, factor it out 1 minus 2, true or false? It means by the time you use this to multiply, you get back this, use this to multiply, you get back this, true or false? So here we now limit x tends to 0 plus, so here will now be x 1 minus 2 all over x. So as you can see, this and this will cancel. You can now see that minus 1 minus, 1 minus 2 is minus 1. So it implies that limit x tends to plus is equals to what? Minus 1. Okay, now we are done with the right hand side limit. So let us move further to consider the left hand side limit, whether the left hand side too will have minus 1. If it does not have minus 1, it means the limit does not exist. Is that clear? Are you following? So let us consider the left hand side. Let us consider the left hand side. So it means the left hand side will now be x tends to 0 minus, right? So here will be x minus 2 absolute value of x all over absolute value of x. Then if the modulus, the absolute value, that is equals to, since it is negative, my value, right, minus, sorry, here is 2, right? Open bracket, instead of modulus x, we are going to write minus x all over minus x, true or false? So what we need to do here is we have to we are going to do the same thing, minus times minus 2 times minus x plus 2x all over minus x. Amen. Yeah. So here we are going to do the same thing. So here is going to be x is common, factor it out, 1 plus 2 all over minus x. Can you see now? So this and this will cancel. So this implies that limit x tends to 0 negative is plus 2 all over minus 1. True or false? So this is 1 plus 2 is 3 all over minus 1. Then which is equal to minus what? 3. So you can now see that limit x tends to 0 minus is equals to what? Minus 3. Look at the left hand side limit and the right hand side limit. What are you seeing? Look at it and tell me. Or ask yourself, are they equal? Are they equal? Yes or no? The left hand side limit and the right hand side limit, are they equal? They are not equal. They are not. So therefore, you conclude by saying since limit x tends to 0 plus x minus 2 mod x all over mod x does not equals to limit x tends to minus x minus 2 mod x all over mod x. So you conclude by saying, therefore, the limit does not exist. Therefore, the limit does not exist. Yeah. So this is how you are going to approach this limit. Should in case you come across it somewhere like this, whenever you are asked to show that the limit exists, first thing you should consider is 1. After showing, the left hand side must equal to what? The right hand side. Otherwise, the limit does not exist. As you can see with this example, you can now see that, look at the right hand side, we got minus 1. Then look at the left hand side, we got what? Minus 3. So we conclude by saying the limit does not exist. But a situation where both of them are equal, assuming here 2 is minus 1, here 2 is minus 1, it means the limit exists, true or false. But for the fact that this and this are not equal, it does not exist. So any question? Do you have any question? Any question? Do you have any question? The left hand side must be equal to the right hand side. Yes, that is when limits will exist. Otherwise, it does not exist. Take note. Okay. Gentlemen and ladies, thank you for your time. God bless you. I wish you all the best. See you same time, same venue, same day. I love you guys. Bye. Have a wonderful day and weekend.